so we got a couple projects we're going to try to knock out this week. First, this past weekend we had a ham fest, basically a place where a bunch of ham radio guys and gals get together and swap gear. Some of the manufacturers are there. So I picked up this, I forget what they call it, but it's this little enclosure that you can swap in different little panels. So I got a voltmeter, Anderson power poles, and a USB, 2 USB ports. And basically you got to take this and you take it home and you wire it up yourself. So I got some, I think it was 14 gauge wire and these little connectors. These little connectors are pretty nice from Lowe's. You just pop the wires in and then it just uses basically friction to keep them in place. So wired up an Anderson power pole, put it to the USB, the voltmeter, and these two other Andersons. So basically, they can take these batteries and connect to this, and then take my radio or cell phone and charge it. But what I wanted to do is build a little box to kind of make this a little self-contained unit. So we have like these batteries and the box all together. So we're going to try that. Other thing I'm going to try is I had some of this cheap foam left over from a recent purchase, and so what I'm thinking about using it is basically I've got a box that I take in my backpack with all my electronics, or my computer bag, and I've got things like a hotspot, a little 3D scanner that I want to kind of maybe see if I can make some sort of like a foam insert to keep all those things. So when I have a little, then I put that in a plastic box, then put it in my backpack and go. So we're going to see how well this cheap shipping foam, it's not the nice foam, but we'll see if we can make it work. I think if we throw some heat at it, it'll work. Some other things. There was some cheap, these little pocket inserts for like a little day planner. They were on clearance at Lowe's or Target. And so what I'm thinking about using these for is making some sort of color filters for my light here. So for instance, here's a blue one. If I put the blue, so you get a little blue tint. Let's try the red. Yeah, there we go, some red tint. And then a little green. So we're gonna try to see if maybe we can make some sort of contraption to hold these, kind of make some cheap color filters. I think they're like $2. And last thing, I've been tinkering with wearable electronics for a while, and it's one of those things where there's no equivalent of like a breadboard for wearables. But I was thinking this is something that Michael's basically, I guess for sewing different, it's kind of like gives you a rigid surface to build or sew or knit or whatever you're supposed to do with it. But what I'm thinking for is, if you have like a lily pad and various sensors that are in a wearables electronic form factor, maybe we can use this because there's these little holes. It's like a little grid, and you could sew your electronics. And because the holes are big enough, it would be easier. It should be easy to pull the wire back out if you make a mistake. So I'm going to experiment with this and see how well we can use this. But it's like 96 cents. It's by a company called Doris. It's a plastic canvas. They come in different colors. I got a clear one, but I'm thinking for kind of like a breadboarding wearable electronics, this might be the thing to do. And then even when you're done, if you don't want to, waste time, maybe you can then just cut out the section and then sew that on to your whatever wearables product you have. Again, there's different colors, so you could probably match close to whatever fabric you were using for a final design, but I'm thinking somehow this could be a breadboard for wearables. So that's it for this week. We're going to see how these work.
Alright, so first we're going to start with the foam board project. Obviously, as you can see, the first thing I did was take all the crap that's in my box, all the gadgets and gizmos, and laid them out on the foam board, just trying to get an idea of, how much I could get on a board, how much can I arrange, and can I arrange in a way to optimize the space. So I played around with that for a little bit, and then when it was ready to go, I took the box, inverted it, and pressed it down to kind of give me a nice little outline. Then I used a little hot knife to cut it out, and that was a laborious process. I don't know if the hot knife I was using was a cheaper one, but it took a while. I noticed if I did an up and down motion, that seemed to help. I don't know if that's what you're supposed to do anyway, and I just didn't know. This was my first time cutting foam, so. But eventually it all worked out, and we got the board cut out so that we could fit it back into the plastic box. Alright, so then I took all my little doohickeys and took a magic marker and drew an outline of all of them. Then same thing, I took the hot knife and tried to not go too far down. Try to match the thickness of the object. Then I took a little chisel, cut it out. Didn't work too bad. I put a little butane torch in the bottom to help kind of melt the plastic so all the little styrofoam balls didn't pop out. That seemed to work. Then cut everything else out, finished it up, put everything back in, and voila. Alright, next project of the weekend was the battery box. So basically, some folks like to sketch things out in like SketchUp or some other 3D modeling program, and I'm much more of a tangible, physical, kind of touch it, feel it, figure it out kind of guy. So I sat there with my raw material and just try to figure out how could I get the two batteries with the least amount of space. And here I'm just trying to figure out, should I do a GoR somehow? So I some of these cheap little hinges from another project. And eventually I decided to mount it from the top so that you would have to open the flap upwards to get the batteries out. That way when I was walking around, the gravity would push it forward. Alright, so I'm just going to go ahead and whip the raw material down, cut it down to the right dimensions. And I took it over to the router and basically cut a 1/4 inch, about this is I think this is using 1/2 inch board, so I'm about use a 1/4 inch bit, did about 1/8 inch deep all the way around, so the top and bottom of the box. And I'll have 1/4 inch plywood, connect the sidewalls. Here I'm just cutting around this place to put the sidewalls to have a little place to tuck them in. Notice I got to really work on the lighting. The lighting is really, I thought it was brighter. Then I got a little drill bit, I guess a spade drill, and basically I put a hole in the top of the box so that the wires that feed up to the voltage meter and the USB. Slow and steady wins the race. There we go. So that was it took a few minutes. There we go, nice little hole. You can see the edges there real quick. Alright, so next up, just figure out, yep, it works. That's time to glue it all together. So we got all the pieces cut. Do a little dry fit here, just to make sure my thinking worked out. So again, glue it up, and then we'll put some clamps on it and let it dry overnight. Clean it up a little bit. Alright, there we go. 1 battery and 2 batteries. Perfect fit. I'll just play out real quick how I'm going to do the door. I wasn't sure if these are sealed lead acid batteries. I'm not sure if they need to have ventilation. So the way I'm going to mount that door is so that there's like a little bit of an edge opening around the edge of the door, so that way if it does need venting, I don't know if they do. I don't know if it's like lithium ion or whatever, but just to be safe and sorry. So sanded the box down a little bit, and then I'm going to go ahead and chisel out the place for the hinges. This is the worst part. I am not good at this whatsoever. I don't know why. Chisels and me just do not get along, no matter how sharp I make them. And then everything here at this point I'm going to hand tighten because it's so thin and don't want to mess it up. Then I took some tape, taped it around, stained it, and then I wanted to do kind of like a racing streak around the middle, just because there's no good reason. So again, let that dry, and then came back with some linseed oil, and I did the middle band there. Not too bad, not too shabby. A little character. It's not going to win any design awards, but it's something. And this was an afterthought. So I'm basically now going around the sides and drilling holes all to the side, and you'll see here why I did that in a minute. So yeah, just took my time and made different diameter holes. Kind of an artistic thing. Oh, and before that I used my little butane torch to kind of like burn the wood edges of the holes. It actually turned out pretty nice. And then here we go, LEDs. So, and I forgot to mention, somewhere along the line I spray painted the inside this green because I just like the color green. So we're going to take this LED strip that I got just a couple bucks, hot glue it all in there. Yeah, and then we'll have basically a little nightlight inside. So go ahead and clean it up. Oh, one more. There we go. Turn the light off. There we go. So now the little box glows and the holes let the light out. Then the little Velcro on the bottom again, just so that the door has like this, about 1/8 of an inch seam all the way around that's open. I don't need it now that I had the holes drilled, but I didn't think of the holes initially during the project. All right, time to mount the electronics. So we'll get that all figured out. Again, I'm going to hand screw everything on just to be safe. At this point, I don't want to damage anything. And voila. Alright, so we put the wires in. I'm going to test this just with one battery real quick. Shove it in, turn the lights on, and there we go. There's the voltmeter. All magic. The battery box is done. Alright, so we also got the plastic cut up here. I've got the green filter on. Just using this little clip for right now till I figure out a better way to hold it down in front of the light. But you can kind of tell there's the little green hue. But then the other colors up on this this is the standard camera mount screw. I've got all the other colors, so you could just take one, flip it around, and then let's see here. We'll pick let's pick red. So we'll throw the other ones back around, and then there we go. Put the red one in front, and again you just clip it up. But anyway, not bad for like $2 at Target. And again, meetings are boring, and I think this is a much better use of your pocket inserts for a day planner. So there you go. Alright, so that's going to wrap it for this weekend. I did not get around to doing the wearables breadboard with that lattice work for sewing, so I'll save that for another week because I did have to get another project done, and I'm proud to say that it is finally finished. My little camera slider that's powered by an Arduino, and look at all that wiring. So that's done. Basically, it's a very simple project, nothing really magical to it. You turn it on. I have a little GoPro on there right now. And you press the one button, and this will slide back and forth, and it'll keep the camera straight ahead. You press the red button, it will start from here, and basically as the slider moves, it rotates to kind of keep the object in the middle. So so it's always focused on the object. So that's it. There's really, again, nothing really magical to it. The source code is up on GitHub, and I'll probably do a little circuit schematic and throw that up there too. But again, there's really not much to it. But what I'll do is I will leave you with what you can get as an end result. So with that, thanks for watching, and until next time, stay quirky.
Now I'm feeling so fly.